the opportunity to be able to work on such an important building. I can't tell you how many times I get stopped, whether it's at the hotel or the gas station, hey, you guys are working on the Capitol. It means so much to the people of West Virginia. It means a lot to us, to be able to be a part of it is just super, super cool. All of the work that's going on up above us will stop, allow us to enter into the work zone, and then we can take a look around. And the interior scaffold primarily is used to access the interior walls and the bottom of the inner dome. So all of the work that's being done to repair the water infiltration on the inside of the walls, this scaffold system is self-supporting and is used to access those areas to repair the interior finishes and also strengthen the walls. So where we're gonna go back up and take a detour to the 4th floor catwalk. Once we get onto the 4th floor catwalk, we'll be able to go up and actually check out the work area. What this area is primarily for is to bring in all of our tools, equipment, and materials from the south portico into the bottom of the scaffold, and then we have man lifts that travel the full height of the scaffold to be able to transport tools, materials, equipment. So these are the clay tile that actually come out of the wall at the colonnade level. And these are the clay tile that we're going to be replacing as part of the construction project. We're at the colonnade elevation, and in between the windows, this is the existing structural clay tile that's in place. It's going to be removed and replaced as part of this construction project. The water damage that you can see ultimately led to the reasoning to investigate and perform the construction project. Once it was investigated and the walls were opened up, then it became much more apparent the serious need of removal and replacement and restoration for the inside. And so as part of this project, all of this interior wall surface will be removed and replaced. New finish, new plaster, new paint. So again, we're gonna paint from the catwalk all the way up. And then if you look at the elevation at the bottom of the windows, so where the red panels are in between the windows, we are going to remove and replace the interior wall system from the bottom of the windows all the way to the bottom of the dome. That'll be completely removed and replaced. Those panels with the original painter's signatures from the 1930s, we've cut those out and salvaged them, and then they're going to be reinstalled with all of the new interior finishes that go in. So we'll be able to preserve the interior finishes that were originally signed by the painters. One of the amazing things that we get to be a part of is working with the engineers, WDP and Associates. They do a tremendous job of paying very close attention to not only the historical preservation that needs to happen, but also to the structural integrity of the building and making sure that it's safe, that longevity is very important. So it's been a really great pleasure to work with an engineer that cares so much about the building, shares the same passion and emphasis on safety, quality, and doing the right thing. It's been a really amazing partnership, and they do a great job. So we're at the dance floor elevation. We use this elevation to access the inner dome. What we're doing here is stripping all of the blue paint. We're reinforcing the existing dome by installing supplemental anchors. The rectangle anchors hold the domes together, and then also applying a strengthening solution using glass polymer GFRP, and we've strengthened the inner surface of the dome using that GFRP system. Once all the GFRP is on and all the anchors are in, all the paint gets stripped, it'll all be repainted back to the original color, glazing, pattern, everything will look exactly like it did before. This is one of the parts you gotta watch your step and watch your head. This is the inner dome space, they call it. And what you're looking at here, the part of the dome, this is the actual top side of the blue dome that you see from underneath. So when you're in the building proper and you're looking up at the blue dome, this is the top of it. So we had talked earlier about the need to support the dome with those new permanent shoring brackets. This is the other system that holds the dome up. They call this the tensioning system. And so this tensioning system is made part of the dome system and is secured to the concrete winch deck that's above us. So this in essence holds up the entire dome structure. The major part of the construction scope on the outside is the removal and replacement of the limestones that are at the spring line elevation. And so each one of those stones weighs approximately 2,000 pounds. Each one of the 192 stones had to be removed from the building, brought down to the ground, cleaned, inspected, repaired, and then they all get reinstalled once they get back up to elevation. So we do that by using our custom engineered rigging systems and carts. So this is actually one of the stones that's getting ready to go back up to be installed. So the piece of limestone weighs approximately 2,000 pounds. And this was the primary source of water infiltration into the building. There was no flashing that was installed during the original building construction. So when water came off of the gold dome and went directly behind the masonry, behind the limestone, and directly into the building. So once the limestones are picked up at the spring line, they're placed onto a cart. The cart comes over to this hoistway, and the stone is hoisted down through this elevator shaft, along this racetrack, over to the other elevator, and then the elevator takes it down to the ground. Once it's on the ground, it's cleaned, inspected, and repaired. These are some of the stones that have already been cleaned and repaired, but we don't repair them back to brand new type of a condition. The state and the engineer were very cognizant of the fact of the historic preservation and kind of leaving things that are unique and have character. And so like some of the erosion marks on the stones, that's from water over the years, just coming down over the stones. Those are things that weren't fixed to make sure that we kind of maintain that flavor, that character of the original building and its original characteristics. But now with the metal flashing system, the water is still allowed to penetrate through the stone, but essentially we have a system now to stop it from getting in the building and bring it right back outside of the stone facade. One of the unique features of the dome scaffold is that the dome scaffold itself cannot touch the gold dome. It had to be uniquely designed and engineered in order to be self-supporting and not bear on the gold cladding that makes up the dome. So that was a really big engineering challenge that we overcame. Had some really smart people working on it and putting together the design for the scaffold. So when you go up there and you take a look, you'll notice that none of the scaffold members, nothing is actually touching the gold dome. It's completely dependent on its own structure. Before the scaffold was erected and we had normal means of access, the only other way to get up to the dome was the spiral staircase. That was kind of daunting, to go up and down, especially in cold weather or rainy weather. So when it comes to historic preservation, these are obviously materials that were installed in the 1930s. And so historic preservation is a big part of cleaning and repairing these types of materials. The craftsmen that are part of this team have undergone special training through the IMI that teaches them the actual methods used back during the original construction days on installing, repairing, and taking care of it.